This is a video from the topic C1 looking at ionic bonding. Now if we first go to the noble gases, okay, this is group 0 on the periodic table, they're all really stable. They have full outer shells of electrons which make them really unreactive, really stable, and we call them inert, okay? We say that they are the inert gases. Here we've got lithium, and on the left hand side we've got a lithium atom. Lithium's in group 1, the alkali metals, so it's got 1 electron in its outer shell. 3 electrons in total, 2 on the first shell and 1 on the next shell. So we can say that the electron configuration is 2.1. And lithium is very reactive, reacts with oxygen, reacts with water, and when it's reacting, it's losing an electron, and that way underneath it has a full shell of electrons. Now there's 2 options here really. One is lose that 1 electron. 2 is gain 7 electrons. It's going to be a lot easier to lose 1 electron than it is to gain 7. So that's what lithium does. Right hand side there we've got a lithium ion, and you can see that extra electron on the outer shell is now gone, so the electron configuration is just 2. We represent ions with these squared off brackets, so we can see that that's an ion, and then on the corner of that bracket we can see there is a positive charge, because in the lithium atom there were 3 negative electrons and there were 3 positive protons. Now the protons are still there, so 3 protons, but now in the ion only 2 electrons, so effectively there is 1 extra positive charge. Not that it's gained an extra positive charge, but it has 1 more positive than it does the negatives, okay, so we say it is a positive ion. If we have a look at beryllium next, beryllium is from group 2 on the periodic table. So beryllium has an electron configuration of 2.2 when it's an atom, so 2 electrons on the first shell, 2 on the outer shell, and that's why it's in group 2. So when beryllium reacts, it's losing 2 electrons, and we can see on the right hand side it's become a beryllium ion, and that ion has a 2+ charge because it's lost 2 negative electrons. It's still got the 4 positive protons and 2 negative electrons, so overall it has 2 positive charge. Let's look now to group 7, one of the halogens. This is fluorine. Okay, fluorine, I've drawn it with dots and I'll explain why shortly. Fluorine's in group 7, 2.7 for the atom electron configuration, so it's got 2 electrons and then 7 electrons, leaving this gap of 1. And we'll go back to what we said about the lithium. What's easier to do, gain 1 electron or lose 7? And obviously it's gain 1 electron. So we can see on the right hand side we've got a fluoride ion. Okay, now the ending on the non-metals, the ending changes, so fluorine has become fluoride. Okay, and when we look at some compounds, hopefully that will make sense. So it's gained an extra electron. We can see that the electron has come from somewhere else because they're all represented as dots, and then we've got this 1 cross. Okay, again we've got those squared off brackets, and we've got 1 extra electron, so we have a negative ion, and we've got the negative charge on the outside of the brackets there. Let's look now to oxygen. Oxygen's in group 6. Okay, so you can see on the left hand side we've got the atom, which is 2.6. We've got a missing gap of 2 there. Oxygen being in group 6, so 6 electrons in the outer shell. And then when it becomes an oxide ion, so again the ending has changed there with the non-metals, it changes. You can see the 2 extra electrons it's gained to complete that outer shell with the 2 crosses there. And because those electrons are negative, we have a 2 negative, 2- charge on the outside of those squared brackets. So those are some of the common ions that are formed. Let's have a look at putting those together as if they've reacted together and made some compounds. Okay, so here is lithium and fluorine, okay, and we can see on the top diagram that that electron from the outer shell of lithium has moved to join the outer shell of fluorine, and that's created lithium fluoride. Okay, so that's now an ionic compound. So you can see that movement of the electron over to the outer shell on fluorine, creating a positive lithium ion, a negative fluoride, okay, so remember that ending's changed, fluoride ion, and the structural formula of that is LiF, okay. Let's have a look at another one then. This is beryllium from group 2, oxygen from group 6. Again, you can see here, beryllium needed to lose 2 electrons. So you can see each one of those electrons moving over to the oxygen, which needed both of them. The beryllium became a 2+, so 2 positive ion, and the oxygen gaining those 2 negative electrons became a 2 negative ion. So that's beryllium oxide, BeO. Let's look at one that's a bit more complicated now, okay? It's on a different colour card because it's kind of stepping up to our most difficult level of ionic bonding. So here we've got lithium oxide. Lithium, group 1, needs to lose 1 electron. Oxygen, group 6, needs to gain 2 electrons. So one of those gained electrons that oxygen has comes from one lithium atom. The other one comes from another lithium atom. So effectively 2 lithium atoms help out the one oxygen atom, creating lithium oxide, which is Li2O. So the 2 is saying there are 2 lithium atoms involved, and there's no number after the oxygen, so it's just one oxygen. Okay, Li2O. Let's use the same principle to look at beryllium fluoride. Beryllium from group 2, fluorine from group 7. So it's kind of the same principle, but in reverse. This time the beryllium's giving away the 2 electrons, but fluorine, each fluorine only needs 1 electron. So one of those beryllium electrons goes to one fluorine and one goes to the other, creating beryllium fluoride, BeF2. So the Be, there's only one beryllium atom involved, and the fluorine, there's 2 of them involved. That's what that 2 is representing. Hopefully that's a good summary of formation of ionic compounds, ions. I hope you found that useful. Thank you.